Okay, last question, number 7. One part of Alessandra's job as a doctor is to record the heights and weights of her patients. The table shows the heights X and the weights Y of the past 8 adult patients she has had this past week. All right, so here we have our scatter plot. Notice that we have height in inches on the x-axis, weight in pounds on the y-axis. We're given several data points of each patient's height and weight. Letter A says use the given linear model to complete the table with the residuals. So the linear model is here. Okay, this is the equation of the line of best fit. So if you think about that line of best fit, again, this is a sketch. It would look something like that. Remember that 9, that's your slope. Negative 460, that's your y-intercept, right? X represents the inches a person is, and y represents the weight. So we're going to go ahead and make some predictions about how heavy people would be if we know their height. So the first one is 66. So if someone is 66 inches tall, we're going to go ahead and substitute that in for X. And I'm going to get a blank piece of paper to show you what that would look like. All right, so here's my line of best fit. Y equals 9 times X plus, or I should say in this case minus, it's going to be minus 460. And that's going to give me my predicted Y value. Okay, so let's go with a pencil. All right, someone is 66 inches tall. We're going to go ahead and do the math. Nine times 66 minus 460. That's going to give me a predicted weight of 134 pounds. Okay, so just to sort of organize this, you have your actual weight and the predicted weight. Okay, so if the actual weight of a person that's 66 inches tall, if this person was 125 pounds, and their predicted weight was this 134, all you're doing is subtracting these two. So you're going to do the actual Y value, their actual Y, minus the predicted Y. So 125 minus 134, it's going to give me a negative residual. The difference between these two, 125 minus 134, is negative 9. So negative 9 is going to go right there. Okay, I'm going to erase. Not the best pencil. I'm going to do 2 more examples so you can kind of get the hang of it. And then I might have to fast forward a little bit. So next one, 70 inches. So 70 goes in for X. So 9 times 70. It's going to give me 630, I'm sorry. 630 pounds. Wait, that's not right. I have to subtract 460 because there's no way someone weighs 630 pounds unless they're an outlier. And we don't have any outliers here. All right, I know that's a little too high. Okay, so it's 170 pounds is the predicted weight. The actual weight of the person is 160. So again, you're just doing 160 minus the predicted 170, and you're going to get a residual of negative 10. One more example. This time I'm looking at the third patient. The third patient, they are 73 inches tall. So 73 is going to go in for X. And when I do my math, I'm going to do 9 times 73 minus 460. Okay, and I get 197. 197, that is my predicted weight. The actual weight of that person was 210. All right, 210 minus 197, that is going to be positive 13. Okay, now I'm going to do the rest pretty quickly on my calculator to give you the answer. All right, 74 times 9 minus 460, it's going to be 206. Their actual is 165. 165 minus 206. Ooh, man. This person is really, really an outlier. Yeah, wow, they're really different. So we would expect them to weigh 206 pounds, but they only weigh 165, so they're quite underweight from what we would expect. All right, next person, 61 times 9 minus 460. We would expect them to weigh 89 pounds, but they don't weigh 89 pounds. They weigh 115 pounds. That has a residual of 26. 62 times 9 minus 460 is 98. 140 minus 98 gives me 42. Another point that's quite off. All right, and then 74 times 9 minus 460, I get 206. They actually weigh 200 pounds, so they have a residual of -6. Man, all right, is the line given a reasonably good fit? Explain your reasoning. Man, the line here, I would say yes, because you have 1, 2, 3 of your points above the line of best fit, so positive, 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 and then you have 4 points, 1, 2, 3, 4 that are negative. And also, as you can see here, your points are quite scattered and there's no pattern here. So for this one, an exemplar answer would be yes. I want to say the y values are spread out among the line of best fit. All right, question C says, explain the meaning of the slope in context. So take a look at your slope here. Your slope is going to be 9. So looking at that 9, oh, I'm sorry for the whimpering dog. The 9 here, it's going to tell me that for every, yeah. Okay, so for every inch that you grow or every inch that you are, the weight is going to increase by 9 pounds. So like as X increases by 1, Y increases by 9. So as the height goes up by 1 inch, the weight predicted goes up by 9 pounds. Last one, describe the correlation between the variables as either strong or weak and either as positive or negative. Explain your reasoning. So the correlation here, I would say you have to find the R, but based off of the dots, I would say looking at that correlation, I would say it is a moderately strong correlation. Obviously knowing the R value would help us, but you're going to base it off of the picture right here. It's a moderately strong correlation. It's positive, so I'm actually going to say it's a moderately strong positive correlation. Because as X increases, Y is also increasing. Okay, so in general, you would say that the two variables have a linear association and they increase together.